Hello, once again, everybody. We are live here with our Wednesday night office hours. This is our second of two sessions that is going to address the dreaded summer packet. Should I say the dreaded? That's not good. It's not, that's a bad word to describe the summer packet. The very helpful and beneficial summer packet. That's what we're going to call it. I know it's a very long summer packet as well. The good news is those of you that are starting my class this week, I guess you're going to be in there tomorrow. You don't really have a long assignment, not really a math assignment that's going to be given to you in class tomorrow. So this will be something that you can still kind of work through the weekend, as it's going to be due, I believe, the next following Monday, right? So as always, what we're going to do is we'll take any questions that you guys have in the chat. You are always free to unmute yourself. I know that that's a little scary sometimes, especially knowing that this is going to be recorded and other people can watch it later, but hey, it's just whatever you guys feel like doing. I don't have a lot of things that I have canned that I was going to show, just maybe a couple of things, but most of the problems that people have had the bulk of the trouble with seem to have occurred on topics A through D that we covered in the first video. So I'll let you guys kind of focus on that. They're in the chat. You can send a problem to me. While you are all thinking about that, a couple of things I wanted to focus on. I know I talked about this in the first video, but there is a little typo in the front page or on the front page of the packet. Remember that topics are through you. This 10-point score here, that's not going to be scored until October 25th. This would be a completeness score, not a correctness score. And I want to focus one more time on the big thing I know that you guys are the most concerned about heading into Monday, August 2nd. That correctness score out of 15 is not going to be the 15 hardest questions from topics A through Q and topic B. I promise you, they're going to be middle of the road to the easier ones for you guys. And then I will be taking a look at the other problems throughout that span, which is the majority of the packet, and just checking to see if you made some fairly decent attempts at some of the problems, and then you would get the complete, the maximum completeness score. I know that a lot of you are relying on the internet to help solve these. That is exactly what I want you to do. Some of you, when you're really not sure, you're like going to photo math. You're going to probably freak out when you hear me say this, but I'm okay with that. I'm totally okay with that. As long as you look at those steps that photo math provides and you kind of understand how to get from point A to point B to point C. Hopefully you're just not all photo mathing every little problem and not really looking at the results, because it's probably going to be kind of a waste of time to do the packet. But the point of this packet, in addition to just learning or relearning some of this mathematics, is to learn how to kind of be resourceful and find answers in certain places. So that's the plan. That's the plan. So I've got some problems coming in here in just a little bit through the chat. So as those are filtering in, I'm going to focus here on topic C just really quickly. It is perfectly okay if you're using your graphing calculator. It's okay if you're using Desmos to graph these. We're going to talk about these a little bit in class on our first day of school to make sure that you guys kind of understand the expectation on sketching these. But by and large, this group of problems should be pretty chill, pretty easy. All right, hey, we got some problems, man. Not a problem at all. Hey, that's going to give us a great place to start, and let's just do that. So once again, welcome those of you that are joining us. We are taking a look at topic G. Is our first one that we had a request on it. Anytime that you guys have any problems that you want me to take a look at for you, you can just type them in the chat. If you want to put them in the open chat, that's fine. If you want to just DM me directly the problem, that's totally okay. So we're going to look at G problem 3. And I'm glad that you had asked about this one, because it was one that was going to kind of pop up on the radar, because a lot of students are not quite sure what one of the words means in these directions. It says, find the equations of the lines through the given point that are A, parallel, and B, normal. And it's this word normal that's kind of bizarre. And I get it. It's not a word that I think you see at all in Algebra 1 and maybe even college algebra. So I want you to think of the word normal as being the same as perpendicular. Now, I know what you're all going to say. You're going to be like, well, wait a minute. Why don't they just use perpendicular? Well, there's a reason. Typically, perpendicular is meant to be the word to describe two lines that cross at a right angle. Normal oftentimes is reserved for a curve and a line that cross at a right angle. And I know that seems kind of strange. How can a curve have a right angle to it? That's calculus for you. We're going to talk about that in great detail later on. And then sometimes you might have a curve and another curve that intersect each other at a right angle. If you zoom in enough, those are going to look like right angles. And we use the word orthogonal sometimes for that. But don't worry about all of those terms right now. This idea of normal, is this the same as perpendicular? And so we're going to go ahead and run through this, at least one of these examples. And I think I wanted to look at part B, if that's okay. So find the equations of, find the equations of the lines through the given points that are parallel and normal to this given line. Well, obviously, before we can write the equation of any line, we need two very important things. Most of you guys are probably pretty good with this. You need a point and a slope, right? A point and a slope. Why is a point and a slope so important? Well, because we can use this really cool thing called the point slope formula. And you guys are going to use this formula. I'm not exaggerating. I'm going to say 50 times all throughout AP Calculus. From the beginning of class to the day that you take the AP exam, will be about 50 different times that you guys will write the equation of a line. And it's really not difficult. It's just the calculus that's going to have to be used to find the slope. So to find the point, well, hey, we don't have to look very far. Boom, there it is. But to find the slope, you have to think about what form do you want a line to be in to find its slope? What's the easiest form? And that would be y by itself, right? We call that slope intercept form. We don't really use slope intercept form a lot in calculus, as point slope form is a lot more popular. But if you just get this y by itself, boom, here you go. Doesn't really matter what the y-intercept is. It's ugly, right? 7/2, because we're just going to focus on that slope of -5/2. Just so you know, some of you might be really on top of things, and you might have like a shortcut to find slope that when you've got ax plus by equals c form, you just take the opposite of the x coefficient, divide the y. That's correct. That's always going to give you the slope as well. So for parallel, what do we need to know about parallel? Well, for parallel, we need to know that the slope that we want is the same, right? And so you take your y minus the y value and set that equal to the slope quantity x minus -6, which I could just call that x plus 6. And you guys, this is going to probably come as a shock to you, but I am perfectly okay if you leave your answer like that. In fact, when we move into calculus and we write the first equation of a line, in about 3 or 4 weeks, I want you to leave it like that. I have graded so many AP exams in my career where a kid will have this right, solve it for y, and make a mistake. And unfortunately, the student can't earn the point for that. And so we like to play it safe by leaving it in slope intercept form. And then for part B, you just use the idea of the normal or perpendicular. And what do we know about slopes of lines that are perpendicular to each other? Kind of having you think that through a little bit. Blast from the past from maybe Algebra 1. You take the opposite and the reciprocal, right? Basically, you change the sign and flip the fraction upside down, and that's going to be your new slope. And again, I'm perfectly fine if you leave the equation like that. Now, let's play just in case. What if? What if problem 3B is one of the questions that I might end up grading on Monday, August 2nd? And the way that I'm going to grade these, it's kind of weird. I'm going to send a file to you on the TI Inspire, and you're going to like input some information in it and you're going to send it right back to me. And a lot of the problems that I will ask about this, I've turned them into multiple choice. Even though they're not multiple choice problems on the packet, it makes it much easier for you to input your answer much quicker. It's possible that maybe my multiple choice answer might solve for y. I'm not saying that it will, but it might solve for y. So if that's the case and you want to simplify this now, great, but you would have just a couple of, a minute or so that you could solve it for y on the fly if that were the case. So hopefully that makes sense for problem B. I think A is going to be pretty straightforward. Now, part C is going to be really weird because we have to figure out what the slope of this y equal -2 line is. And hopefully you're all kind of thinking that y equal -2 is a line that looks like this, right? It's a horizontal line down here, and y is 2. And so therefore he has a slope of 0. And so when you do your parallel line, you're just going to use this point slope formula, but put a 0 right there, which kind of makes things pretty simple and disappearing and all that kind of fun stuff. And maybe for part A, wouldn't it be cool if maybe you guys could just write this as y equals something? Now, for the normal line, this is where things get a little weird, right? So there's your parallel slope, 0. But what about your normal or perpendicular slope? Okay, well, let's take 0 and make it negative. Okay, that's -0. That's just weird. And then let's take 0 and flip it upside down, which is really weird because you're going to have a fraction with a 0 in the denominator. Like if this was 0 over 1, now we're going to get 1 over 0. Can't happen. And so you have to think about the fact that this is going to have an undefined slope. And an undefined slope is characterized by a vertical line, right? A vertical line. And so you have to think about what does the equation of a vertical line look like? I'll give you a hint. It's not y equals something, it's something else. And hopefully that'll help you out a little bit with that part C. So, all right. Let's go ahead and keep up. We're going to keep going here with Ian's questions. Let's go to topic H. We got some of these still marked from the other day. Oops, topic H. And we're taking a look at problem 9. The directions are solve each equation for x over the real number system. So problem number 9. So here's our pretty ugly looking equation that we have to solve. And so what I'm trying to kind of extract from this particular kind of group of questions is like, what are the strategies that you would use to get x by itself? And typically speaking, the higher the degree that you see associated with x, maybe the tougher or the more challenging it's going to be. So in this particular case, we have a 4th power equation. And so really the only way that you're going to be able to solve this for x is to start factoring it. I mean, we've got to get a lot of help from factoring. I don't want to take you guys on the synthetic division journey that some of you may have learned in college algebra. We're also at the mercy of the fact that if you took college algebra 2 years ago, then you may not have seen as many things as the folks who took it last year because of COVID. And I'm going to be very sensitive to that. And I'm not going to hold people accountable for things, and I'll have to teach some things over. And I get that. So for problem 9 here, what we want to do is factor. And what we're going to factor is the x squared. Why? Because it is the only thing in the problem common to all 3 terms. Can't really bring out a number, can we? Thought about bringing out a 2, but that 15 is like, nah, I'm not really digging it. Now, I'm hoping that we can continue to factor. And the way that we're going to do that is by breaking this trinomial, hopefully, into 2 binomials. I'm certainly hoping that this works, because if not, I don't like the problem. It's probably something that I don't want to waste your time on, and I think it does factor. Now, the factoring methods that you all learned from your Algebra 1 teachers in the middle school weren't terrible, but the diamond method and all those kind of gimmicky things, they only last so long because you can forget gimmicks really, really fast. And so what I wanted to do is foster some just number sense here. Thinking about, okay, if I unfoil this 2x squared has to be the result of these first two terms being multiplied. And the best way to make that happen, really the only way to make that happen, right, is a 2x and an x. And we are guaranteed that those are going to be those two values. Now we look at the back end, the 18, and we think that's where things get a little rough, you guys. An 18, it could be a 9 and a 2. It could be a 6 times a 3. Even the order of where we put the 6 and the 3 and the 9 and the 2 make a difference. For instance, if we put the 9 here and the 2 here, I think that's bad. Do you guys see how this is bad? It's actually close, but not close enough, because we're going to get an 18x and a 2x. And there's no way that you can either add those or subtract those to get a negative 15x. And so 9 and 2 in those two spots are not good. 9 and 2 in these spots, I don't think are going to work either, because that's going to be a 9x and a 4x. 9 and 4 add to make 13. They subtract to make 5. Neither one of those is this negative 15. So 9 and 2 are bad. Let's go 6 and 3. All right, I'm going to play dumb here. I'm going to put the 6 here and the 3 here. And I don't think this works, does it? Because you get 6x and 6x. So if we maybe, if we maybe switch the 3 and the 6, play our cards right, let's see, a 3x inside and a 12x. Any chance that could give us a 15x or a negative 15x? And the answer is yes, right? Now you have to put your signs in there correctly. In order to get a positive 18, both of those signs have to be either both plus plus or both minus minus. By virtue of this one being a minus, our decision is made. Those have to both be minus. I know it's a lot more work, and I'm kind of like breaking this down into like the bare essentials. And I know some of you that are either watching this live or will be watching the recording are like, okay, man, I get it. I can factor fast. You don't need to go that slow. You'll be surprised. There's some kids that I have coming into calculus that don't factor really well. But you know what? They can do really well on the AP exam still, because there's not a whole ton of factoring on the AP exam. And I want to make sure that I give those students a fair shake. All right. So what we're going to do to finish this is we just set each individual part equal to 0. We're using the 0 product property. Some of you don't even have to show this step, right? Whoops. You know, make this equal to 0. If you don't want to show this step, that is perfectly okay. In this problem, what I minimally want to see is the factoring. So x equals 0, x equals 3 over 2, right? Positive 3 over 2, and x equals 6 would be the answer there. All right. I'm going to just take these in order as best I can. So I think I'm going to go ahead and move to I at this point. And just kind of get some clarification on I. Don't have a specific question on I, but I think I can certainly give you guys a bit of direction with this that will help you. And then we can move on to your questions as you guys on JK and L. But you've got two kinds of asymptotes: vertical asymptotes, horizontal asymptotes. So I'm just going to really quickly kind of give you a shortcut here. If you're looking for a vertical asymptote, the shortcut that you all learned in your algebra class was to take your denominator and set it equal to 0. Asterisk. Asterisk. There's a catch. This would only be after you've done any kind of canceling first. That's really, really important. So I want to try to find a problem that kind of has that characteristic. And I think number 4 might be the one. And I want to double check because I don't want to do problems that, oh crap. Yeah, I don't want to do 4, you guys. There's a reason. I could still talk about 4 though. I'm going to still talk about 4. You guys probably just got a big hint. I wonder what's going to be graded for correctness. So on number 4, when you see this, you're going to want to go ahead and factor. All right, any of these problems that has any factoring, you want to take care of that first. So in the numerator, we can pull out a 2x, and that gives us an x plus 3 hanging around. And in the denominator, hopefully you all see that this breaks into 2 binomials, x plus 3, x plus 2. Now here's the deal. Here's the deal. We have a cancellation. Hopefully you see that, right? If a factor cancels, that means it's a whole. So you would go ahead and you would set that factor x plus 3 equal to 0, and it's probably not going to be really difficult for you to figure out for what x value that there's a whole. But if you have a non-canceled factor, that's going to be that denominator that I talked about here. And then you can set this guy equal to 0. Okay? So that's how you find your vertical asymptotes and wholes. And by the way, we're going to go over this very thoroughly in the middle of Unit 1. The difference between what we do with it and what you did with it, say, in college algebra, is I'm going to apply calculus. So I'm going to use the idea of the limit, because that is what defines these kinds of asymptotes. Now, the horizontal asymptote is a little trickier. This one is a result of dividing top coefficient by bottom coefficient. Okay, well, what do I mean by that? So let's look at number 6. For the horizontal asymptote, which I'm just going to say HA, if you notice that the degree of the numerator and the degree of the denominator match, okay, and you want to look for that. The degree is the highest power that you see attached to a variable. So the degree on top is 2, the degree on bottom is 2. If those match, then if you just simply take the coefficients and divide them, that's going to be your horizontal asymptote. So the coefficient of x squared is 1. Now you have to understand that there's like this invisible 1 there. So there's a 1 over 2. And then we want to kind of keep in mind that a horizontal line is a y equal line. And so I would like for your HAs to all be y equal kinds of equations. And for your verticals, let's make those x equal. That's probably going to be a little clearer, because if you solve this, it's going to have an x in it, right? So that's how you find a horizontal asymptote. Now, what if, like in number 5, do you guys see in number 5 that you don't have the same power? You have a 1 on top and a 2 on bottom. If that happens, if the numerator is less than the denominator, 0 is going to be that horizontal asymptote. If the numerator was larger than the denominator, then it just means it doesn't have a horizontal asymptote. And that only, I think, happens on number 7. 7 is the only problem on this page where you would say no horizontal asymptote. And in cases like this, there's not a lot of work, any work that you would have to show. By virtue of you just recognizing those exponents, I would let you get by with that. And do you guys all understand that if you're ever like kind of tricked about these problems, you're totally welcome to graph them on your graphing calculator if you own one, or Desmos. Of course, you are all going to own a graphing calculator tomorrow, because you're going to get one in class for the year to rent. So that's going to be something that we're going to talk about for sure. And then when you get to number 10, 10's a little challenging, because you're going to have to do a little bit of work with the fractions, get a common denominator, and then you're going to be able to do exactly what we just talked about. So hopefully that helps a little bit with the asymptotes in that case. So let me know if it, obviously if it doesn't, but I've got J11 here that we're going to take a look at. And then Catherine, I promise we're going to get to those questions that you put on there as well. So J11, J is, whoops, negative and fractional exponents. This is actually one of the most common things that you guys are going to do throughout calculus, because you're going to find out in calculus that certain kinds of exponents don't play very nicely. And so we have to kind of get them to play nicely with each other by manipulating them a little bit. So trying to get to see, what is this, J11? So this problem right here. I would say just don't work too hard on this one here, Ian. I think this problem, all that is really required of you guys is to note the negative exponent up here, and you would just drop him down to the bottom. So the x squared plus 1 that's already there in the bottom to the 1/2 power, he's going to stay. A lot of students want to move him to the top because it's like, oh, everybody's trading places. No, you only move if you have a negative exponent attached. So this x squared minus 1 drops to the bottom. He's now going to have a positive 1/2 exponent, and then you just have a 1 on top. And that's perfectly acceptable. I know at some point you heard an algebra teacher tell you that you're never allowed to leave a square root or a radical of any kind in the denominator. All right, that is horse pucky. We don't do that in calculus. We don't care about simplified answers on the AP calculus exam. And I know that you're probably surprised that, oh, 11 was that easy. I get questions on this all the time because people think you had to do more. That's all I need. All right. I know that this would factor into x minus 1, x plus 1. If you wanted to do that, that's okay. It's not a big deal that you leave it like that. All right. Moving to K, I had a request for K here, eliminating complex fractions. Problems 8 and 9 seem to be the focus here. And we can certainly help with that. 8's got a negative exponent in it as well, so that's going to be kind of cool. So all that's going to happen with number 8 is, first of all, we've got this 1/3 dividing by the negative 3/4. What I would say to do is just focus on those two kind of by themselves. And whenever we multiply fractions, you all probably remember that whenever we divide fractions, we multiply by the reciprocal, right? And so that's going to take care of just these two guys, right? The first step that I've got. And then if I want to just extend the sentence, I could just simply say, oh, okay, what about this 3x minus 4 to the negative 3/4? Well, that's the part that looks really complicated, but he's actually the easier part, because we're just going to drop him down to the numerator, or from the numerator down to the denominator, and we're going to give him a positive exponent. And you guys, that's all you have to do with that 3x minus 4. Now, if you really want to clean this up, which would be nice, the negative 4 is just going to multiply by those 1s, and we have a negative 4 on top. The 2 3s, of course, make 9. And then again, I am perfectly okay if you leave 3x minus 4 to the 3/4 power. You don't have to put a radical back over it. You don't have to do any rationalizing of the denominator. That will work for me. And I think you guys realize that whenever a fraction is negative, you got 3 options. The negative can go in the denominator, which I'm just going to tell you, that's weird. It's just weird, but it's okay. The negative could go out in front, kind of even with the fraction bar, and that's okay. I will tell you, be careful if you do this, because I've seen students not leave enough space here, and it's kind of hard for me to tell if they meant for a negative to be there or just the really long fraction line, right? Or what I prefer is probably just making the numerator negative. Then it's really easier to tell. Okay. Now for number 9. 9 is definitely the trickier one here, and it's one that I had planned on talking about tonight, even if it wasn't brought up. In number 9, we're going to have to factor. And this is going to be a bit of a factoring technique that you are going to use a bit in calculus. So if you look at the numerator, I want you to think about this numerator as having one term there and another term there. Terms are separated by pluses and minuses. Yeah, I know that there's more minuses inside these parentheses, but we're looking at the big picture. There's only 2 terms in the numerator. So what is the common factor among those 2 terms in that numerator? Well, let's see. I got a 2x here and a 2x squared there. I think we can factor out a 2x. What do you guys think? Agree? Pretty obvious, right? Now the part that's a little tougher. 2x minus 1 to the half, 2x minus 1 to the negative half. Something in common? 2x minus 1 to something, right? And that's exactly right. You're going to factor out 2x minus 1, but the million-dollar question is, to what power? And to kind of bring this back into maybe an easier setting, consider this simpler problem. If I asked those of you that are watching live or recorded, what would be the factor of x squared minus x to the 5th? You would all crush it. You would say, oh, I'll bring out an x squared, right? And that's going to leave you with 1 minus x cubed. But see, I'm going to turn that around. I'm going to ask you, like, why? How did you know that? How did you know that x squared factored out? How come you didn't bring out x cubed or x to the fourth or x to the fifth. And hopefully you would say, well, the x squared wasn't big enough to factor out something like an x cubed. And that's exactly it. You factor out the smaller exponent. So out of 1/2 and -1/2, -1/2 would be the smaller of the two. And now we can leave with what's inside. I tend to use like a little bigger parenthesis there to distinguish between what I factored out and what's left in. The 2x is out. Now, another tricky part, 2x minus 1 is left in, but to what power? That's the next $1 million question. And so a lot of times students are like, okay, this times this to make that. Whenever I multiply like bases, I have to add these exponents, right? If I'm like distributing this to like get back to this original problem. So -1/2 plus what is +1/2. And hopefully you see that the answer is 1, right? And I didn't really have to put a 1 there. I only put it there just to kind of emphasize it. But that's what it's going to be, just a 1. And then I drop down the minus, and then I've already factored out a 2, and we have an x to the first, and this 2x minus 1 to the -1/2 is completely factored out, right? And so this is where we would land. This is topic K for those of you that are just joining us. Topic K. So that's the top. Now the bottom, the denominator, 2x minus 1 is still hanging around. Now I would like you guys to do just a little bit more with this. I would like you to go ahead and simplify the numerator. This 2x is going to stick around. This 2x to the -1 to the -1/2, it will drop to the bottom, become 2x to the +1/2. I'll write it like this for now, times 2x minus 1 stays in the bottom. And then I got all of this stuff here, which, correct me if I'm wrong, but I'm thinking that just gives me -1. Am I right? I'm sorry, x minus 1, x minus 1. 2x minus x is x, and then the -1. And so you're really in pretty good shape here. The only thing that one could do to really simplify this a whole lot would be to multiply the like bases, which means you can add the exponents. Okay, and I know some of you might be sitting there thinking, okay, how am I going to know to do this stuff? How am I going to know that that's what I got to simplify all the way to? Well, first of all, we don't do a lot of that kind of simplifying in calculus. But secondly, any kind of a problem that requires simplifying that you would see in my class or on the AP exam is going to be multiple choice. So if all the multiple choice options look like they've been simplified, that is your clue to keep going. And then you would hope that your simplified answer matches one of the choices, because that's kind of like, Christmas morning, right? You're really happy when an answer matches, but it's the worst feeling in the world when your answer doesn't match. And I totally get that. So that's the extent that you would probably have to simplify your answer on problem 9. So hopefully that helps a little bit. All right, finally, we're going to get to Catherine's question here. I think topic L. Let's look at L number 7, and I think I have to go back up to the top of the chat because some others were also interested in topic L. So topic L is about inverses. Inverses is something that you probably hit very, very, very lightly in college algebra. We're going to hit it a little bit more heavily about halfway through the first semester, and we'll do some really fun calculus things to it. But for right now, I'm just going to give you the basics. Find the inverse of each of the following functions, and it says you can use a graphic utility to show that its inverse is a function. So if we jump down to 7, find the inverse of the following, and we're going to show this. We're going to prove this thing. We're not necessarily going to worry about graphing it, I guess. So what we're going to do to find an inverse, the only thing that you're obligated to do to find an inverse is to flip the x and the y. So this f of x, if it were dreaming, right, it would be dreaming of being a y, right? That's what an f of x dreams about, right? It's like, man, when I look like f of x, people get really confused. They think I'm like a lot more complicated, and I'm just a y. So if we just flip the x and the y, we would have this. Easy enough, right? Okay, now here's what I'm going to do. I'm going to fire up my graphing calculator, even though the directions didn't say that we had to graph this. This is something that you're going to be doing in my class eventually. And so you guys are going to get a little bit of a jump start on it. You don't have to follow along with your own graphing calculator unless you really want to. It's not going to be very sophisticated what I do. You're probably going to be able to remember it. And if you don't have a calculator, it's not a big deal. You could have done this in Desmos just as easily. So I am going to go just to a Scratchpad page. Right? We tend to work in Scratchpad more than we work in, say, documents, like those of you that took maybe AP Stats. And I'm going to go to a graphic page. So just by hitting this button here, it just kind of goes back and forth between Scratchpad, graph, Scratchpad, graph. Okay, you get the idea, right? And so what I'm going to do is I'm going to enter that function, that f of x function that we saw there for problem 7, which was 1/2. So I can go control divide to get that pretty little fraction there, 1/2. Move over to the right with the arrow so I can get my x. And then what was it? Minus, and then another control divide brings up another pretty fraction. And so there's the graph of the original function. Now what I want to do is graph the inverse. Now the problem with the inverse is that it does not have a y by itself. And you'll notice that if you try to like bring up the entry for your equations, which the shortcut for that is tab, it is like no bueno, right? F2 of x implies another y by itself. So we're going to tell the graphing calculator by going into menu, graph entry, and relation, right? See how we're not going to go to function, which was the default. We're going to go to relation, all right? Don't worry if you don't remember that. It's menu 3-2 is the shortcut. But this will give you an entry line, kind of like the entry line in Desmos, where you can just type anything that you want. Check this out, guys. I can type in x equal, and then our answer, I think, was 1/2 fraction, 1/2 y minus 4/5. And lo and behold, there's what we have. Now I'm going to do a little fun stuff here. I'm going to kind of highlight that line. I'm going to hit Control, Menu, and I'm going to change its color because I just don't want both of these to be blue because that's no fun. So I'm going to change the line color to, you know what? I would even ask you guys in the chat, but it takes so long for you guys to answer. It's fine. I was going to say, what color do you want? We'll go with red. All right. So I'm going to move some stuff out of the way. I'm going to show you how to do that on the Inspire this week or next week if you don't know how to do it already. But I wanted to show you something kind of cool here. If I go back into my graph entry and I choose function again, and I graph f2 of x equals x, y equal x, it's going to graph a line, and I'm going to change its attributes as well. I'm going to do two things. I'm going to change it to a dashed line because I don't want it to be so busy. And I'm going to change its color to something, well, something that's not either blue or red. So how about we change it to this, ooh, how about this wonderful orange? Oh no, this magenta, that'll work. So what I wanted to show you here is the relationship between the graph of an inverse and its original function. It has this mirror type of image around y equal x, symmetry around y equal x. And that has a lot of really important results and all throughout mathematics. Like, did you guys know that e to the x and natural log of x are inverses? It's likely that you may not because of COVID and having taught it really quickly. And so we're going to be going back to that. So if we go back to the document, and where is the document? That's a good question. Where is this? Where did it go? Oh, there it is. So if we go back here, the whole idea was not to graph this. It was just to find the inverse. Well, okay, we did. But this idea here of showing that f of f inverse is x, that's the actual definition of an inverse. What that means is if you took the original function f, which is this top guy, and you replaced any x inside of it with what the inverse was, something very cool is going to happen. All right, well, what does that really mean? Well, it means take this 1/2 x, okay, but instead of x, replace this with the inverse, which happens to be this expression, 1/2 y minus 4/5. Ooh, wait a minute. This is going to be a bit of a problem. Yeah, why is this going to be a problem? Well, if I continue to work this out, it's going to be problematic in that this is going to be an expression in terms of y, right? No matter what we do to this, it's going to have a y in it. Okay, not a big deal. Here's how we fix that. Now you're going to be mad at me here because I can do something that you guys can't do. I can like move my stuff down. Can you guys do this when you're like writing? You just like take your pencil and just say, hey, go move. You probably have to erase, don't you? Now this stuff here is going to have to go because I don't want him. So what we have to do is this equation that we just found when we switch the x for the y, we have to solve it for y. So it's not a really big issue. We would add add a 4/5 over to the left, add a 4/5 over to the left, and then we would finish it up by multiplying everything by a 2, wouldn't we? Have 2x plus 8/5 equals y. Hopefully you guys see that algebra, just multiplying through by a 2. And so this y is truly the inverse. Right? Now that I've got the y all by itself, that's truly going to be my inverse. And so what I'm going to do is I'm going to take that inverse, 2x plus 8/5, and it's going to take the place of the x that I have in this function. 2x plus 8/5 takes the place. And then I just kind of pick up where I left off and have this minus 4/5. Okay, so I want to recap this. I'm going to recap this. This was f of f inverse. If this was f of 2, wouldn't you just plug 2 in for x? F of 2 is 1/2 times 2. If this was f of monkey, yep, I said it, f of monkey, you would take 1/2 times monkey minus 4/5. Doesn't make a lot of sense mathematically, but that's what you would do. But now it's f of f inverse. So we replace the x with the inverse. And let's see what happens. 1/2 times 2x, I think that's x, right? Yeah, last time I checked, that was x. 1/2 times 8/5, what is that, guys? That's 8/10 or 4/5, okay? And then I put the minus 4/5 here at the end, and then, whoa, what do you know? The 4/5 cancel, and I got x. And that's what's supposed to happen with inverses, you guys. When you put one inside the other, everything cancels. And that's what's going to kind of largely, you're going to continue to do the same thing with 8 and 9. Maybe a little bit trickier trying to solve for y here. I can tell you on 8 and 9, you might have to think about the role of the plus and minus whenever you take the square root of both sides. Wrestle around with that and see how it goes. And you guys will still have like a couple of days that you can kind of ask me some questions, whether it's in person in class or through Schoology. So, and hopefully that helps a little bit there. Looking back on topic L, I guess we had a question that was specific to 9 with topic L. So I can get that started at least. Let's see how this goes. So remember, the first thing is you're going to flip-flop the x's for the y's, right? And so boom, you're already in your inverse. But the problem is we don't have y solved for. And that's a big issue, you guys. We got to get this y solved for. Otherwise, we don't know what we're going to plug in right here. And so to solve for y, you're going to cross multiply. I'm going to go ahead and distribute that x if that's okay with you all. So there's my cross multiply. And then in order to get the y solved for, I have to get the y's together on the same side. And so how about I just, there's lots of different ways to do this. I could get the y's on the left side. I could get the y's on the right side. Oh, goodness. How about I do this? I'll subtract xy squared over. It really doesn't matter. You're gonna have a weird negative kind of hanging around regardless. So if I factor out y squared, I end up with this. Hopefully you guys follow that okay. And so now if I get y squared by itself, I have to divide over 1 minus x. But y is not yet by itself. what we have to do is take the square root of both sides, which is this. And technically, we're obligated to put a plus or minus there because we've taken the square root of both sides of an equation. And so this kind of brings up a bit of a problem, and it's not something that I really wanted to be the focus of this problem. I really don't. Because the inverse needs to be a function. That's what they are. They're inverse functions. That's why it still has this F notation attached to it. So really what you could do is I would allow you guys to either use the plus version or the minus version. They're both going to work out and give you that X. So I'm going to guess that most of you will be like, well, heck, if I have a choice between a plus and a minus, I'll just use the plus because I like pluses better, right? So just simply use the positive of this, and you're essentially going to just rewrite this function, but replace both of those X's with this thing here. You're going to find out if you use the minus, the negative is going to disappear anyway because you're squaring, right? And you guys understand when you square something this ugly, it's kind of the easiest thing in the world because the square root just disappears. And you know that the answer's got to be X. So, hopefully that'll help you out a little bit on that question. Okay. All right. Kind of going in order here. We've got an N request. N, there's my little heading for M that I already made a separate video for. N, and it was problem number 6. N number 6. Absolute values, problem 6. This one is one of our trickier absolute values, and the reason is because of the quadratic in here. So here's what I want you guys to think about absolute values. If I gave you, say, the absolute value of X and said, hey guys, it's equal to 5. And I said, solve that. I want you all to give me an X. Give me an X that's going to make that true. Everybody in the room is going to say 5, probably, right? 5. But are you guys also thinking of another answer that makes that true? -5, right? And I don't care if you wrote and, or, put a comma. That to me doesn't make any difference, all right? I'll just use the word or. Either of those will make that true because that's what the definition of an absolute value is. If we go to a more complicated equation like this, think about what we just wrote here. What we wrote was the original stuff inside of the absolute value. Oh, okay, 12 minus X, I guess, set equal to the value that was to the right side of the equals, which would be this expression X squared minus 12X. But then we have this other option, or, and you know what, you guys, can I change my mind here? I'm thinking this is going to go on the internet. I might have some colleagues that watch this. They're going to be mad at me. They're going to say, you know what, you really should have put the word and in there. In this case, we probably should. All right, I wouldn't make a big deal out of it in our class, but let's go with the word and. And so what we got here, what we had here was the original stuff inside of the absolute value set equal to the opposite. So we're going to take 12 minus X and set that equal to the opposite, or negative quantity X squared minus 12X. Now we have left the world of the absolute value, which I'm just going to tell you, absolute values stink. You talk about something that does not play nicely with calculus, and absolute value is the worst thing. And so this is what we're going to have to do with those to get them to play nicely with calculus so that we can take derivatives of them and integrals of them and whatnot. And so from here, you just solve an equation like normal. You're going to set this equal to 0. So I'm going to add X over, and I'm going to subtract the 12 over. And I'm hoping that you guys are okay to maybe finish this without my help. That will factor. I will say this factor is kind of weird, doesn't it? Aren't we going to use like a 12 and a 1? Not probably what our first thought would be, but that's the only way to get that -11. And then for this part here, you can go ahead and distribute your negative sign. Nice like that. And then I'm going to add X squared over to the left. subtract 12x over to the left. And guess what? We have another 12 and a 1, aren't we? We're going to see 12 and 1 being used here as well in order to factor that. And when all is said and done, when the dust settles with this, what topic is this? Oh, when all is said and done, trying to think how many answers you're going to get. You're going to get a lot of answers, right? You could have as many as 4 of answers coming out of this. I just want to warn you, absolute value equations are a little finicky. You want to check. Take every answer that you got. It'll take you literally 2 seconds each. Plug those in for X and see if you have a true statement or not. Okay. Absolute value equations, equations with radicals, and equations with fractions have to be checked, because sometimes one of your answers or more can get thrown out because they won't make sense. Equations that don't have those things, you never have to check them, provided that you did the work right. You know that they're going to be correct as long as you didn't make a mistake. But you have to be careful. Radicals, absolute values, and fraction equations need to be checked. Hopefully that gives you a little bit of insight there. All right, we're going to move on to P, and then we got Q coming up. P18. That's a bingo. P18. There's no P in bingo, right? No. All right, topic P is 18. It's all about the exponentials and logarithms. And again, I know that this is a piece, especially for those of you that took your college algebra course 2 years ago, that might be struggling a little bit with. The folks that I have worked with already on this, that were taking college algebra back as sophomores, basically said that they had to watch a lot of YouTube videos. Most every kid that I've encountered said, yeah, this really bothered me. Watching a few YouTube videos did make things a little bit easier. So with number 18, the issue with this is that you have very uncooperative bases, an 8 and a 5, that are no way, shape, or form going to get along with each other. They're not going to agree to be the same base to some exponent each, right? And so what that means is you actually will have to use a calculator. That's really the only thing that's riding on this problem. So how you would do a problem like this is simply take the natural log of both sides. Now, even though some of you, may have had a slightly less than robust experience in college algebra, I know that logarithms aren't new to you because you probably have used them in maybe a science class like chemistry, right? And we'll go into a little bit more detail about what a natural log is and what it does and all that. But for right now, if you take that natural log of both sides, there are some properties that say that these exponents can plop out in front like this and multiply, right? This exponent 2x minus 1, I would definitely put that in parentheses, can pop out in front, and it can multiply by the natural log of 5. Okay. Now, if you're sitting there thinking, what the heck does the natural log of 8 mean? It's weird. The natural log of 8 is asking you a question. It's saying, e to what power is 8? All right. And you're like, e, what the heck is e? Well, e is a number that's really close to 2.71, but it's irrational. It has infinitely many decimal points. 2.71 is this magical number, you guys. It's this magical number in nature because if you look at how things grow in nature, it's always according to this natural value 2.7. Rabbit populations, bacteria populations, it's uncanny how things all kind of point back to this number. And we're going to talk in more detail about that in the second semester. So that's really all that this question is, right? And you can probably imagine that this is a very ugly, ugly answer. Well, it will be, but that's okay because we're going to just finish it up by getting x by itself by doing a couple of different things here. I guess I could divide over 2x minus 1. I could do this if I wanted to. Start it like that. And then if I divide ln of 8 over to the other side, at some point, we're just going to have to make the decision. At some point, we're just going to have to say, do we get a decimal in this problem? And I say we just go for it right now. And so ln of 5 over ln of 8, you just go to your calculator. You don't need a graphing calculator to do this. Any scientific calculator will. So I can make a nice little fraction template. My ln button is Control E to the X. Hopefully you see that little ln there in blue. Anything in blue is accessed by the blue control button. ln of 5 over ln of 8, we said. And I'm going to tell you, your calculator is going to be real smart alecky. It's going to be like, oh, you want me to do this? Yeah, there it is. It just simplified it. It called this 8 2 to the 3rd power and brought the 3 in front. Oh, how clever. Well, that's not what we wanted. We wanted a decimal answer. And so Control Enter will always give you a decimal answer. By the way, if you want that decimal answer faster, if you just put a decimal in either one of those places, it'll get you the decimal right away. 0.773976, you might wonder, how many decimal places do we need in calculus? You have to have 3 decimal places in your final answer. And if you have an answer in a decimal sort of in the middle of a solution, I would say go to 4 places. I will always allow you to truncate. You don't have to raise this 9 up to a 0 and that 3 up to a 4. You can. We can truncate on the AP exam. It's really weird for kids to do that, but that's what I would prefer. We'll just call this 0.7739. And so we go back to the document. We have x over 2x minus 1 is equal to 0.7739. And then from this point on, you're just going to cross multiply. You're going to definitely rely on your calculator because you guys don't want to mess with this decimal anymore. I know, right? Put this like over 1 and we cross multiply. You get x equals whatever 2 times 0.7739 is. Well, let's just go ahead and let the calculator do that because I'm kind of lazy. 0.773, how about a point? How about a point? 0.7739 times 2 is 1.5478. 1.5478. That would be multiplied by x. And then minus 1 times that is, of course, minus 0.7739. And I'm going to let you guys finish this up by adding over, or actually do it however you want. You can subtract the x over and add the 0.7739 over, but you will get a decimal answer for this. It's around 1.4-ish. And for your final answer, as long as you're at 3 places, I'll be happy. That's going to be our rule that we've got to make sure that we stick to, because I've seen so many kids. I've graded AP exams where a kid had the right answer, had only 2 decimal places, so we cannot award them the point for the final answer. We were able to give them points for the work, though, up to that stage. All right, we are now going to go on to Q and take a look at problem 2. And Q's got a lot of weird stuff, right? It's kind of like your little blast from the past. It's like all of the fun stuff that you guys did with geometry. But in problem 2, the directions were here: find the area between the x-axis and f of x between 0 and 5, and sketch the region to verify. And so for f of x equaling 4, we just wanted you to, first of all, kind of look at that as the same as y equal 4, right? Remember what I said about f of x having a dream? He's always going to dream of being y because it's so much easier to work with. So think about, what does the graph of y equal 4 look like? And hopefully you think about that as a horizontal line somewhere right here. And I want to say, I know that there are certain pieces of this packet, graphs that were provided, that were very difficult or next to impossible to read. Please be assured that I will not be grading those problems for correctness. After using this packet so many years, each copy gets kind of like worse and worse. And so I'm going to have to go in and redo some of those graphs electronically. So I just wanted to make sure you guys were aware of that. So there's the graph y equal 4. Now, if I'm going to go between x equals 0 and x equal 5, I want you to think about that as being vertical lines, one of them here at 0, right? In fact, I can kind of draw a red line under him to denote I'm graphing him in red. And x equal 5 would be 1, 2, 3, 4, 5, right about here, maybe? Yep. Okay, but wait a minute, I don't have a region. I don't have any region. I mean, if I had like a if I was a cattle rancher, right, and I had a cow here, this cow could go like anywhere, right? If these were like fences, this cow could wind up in Canada. He could be like swimming in the Pacific Ocean. He could be down here in Mexico, or he could be like halfway to England, right? I got to have another fence. And it turns out that I didn't read all the directions carefully. The x-axis is going to be another line. And so we all know what the x-axis looks like. So now we have a place that our cow can have fun, right? The cow can now be here and he'll be pinned up, okay? But for right now, this cow is going to disappear. And so all you're going to do basically is find out what is the area of this region, and I'll leave that to you guys. That's just your simple little geometry. And I know you might look at this and think, what a weird thing for me to ask, right? Not weird at all, because the beginning of Unit 2 is all about doing stuff like this, or at the beginning of Unit 6, Semester 2. And what's going to happen in calculus? It's going to blow your mind. You guys ready to be mind blown? Are you ready? I am going to teach you how to find the area under a shape like that. Yes, that's what calculus can do. It can find areas of very weird shapes. And I'm not talking about estimating it. It'll find it exactly. You use one of these symbols, right? Maybe you've seen the symbols like that, integral symbols. That's what we're going to end up doing. So hopefully that helps out there on topic Q. Had another question here in the chat. The packet is not due tomorrow. No. On the first day of class, what you guys are going to basically do is I'm going to get you really acquainted with the graphing calculator, show you some things that you probably haven't used it for even in your stat class or your college algebra class. We're going to have an activity, a game, a kind of get to know each other game on the Inspire. And basically at that point, I'm just going to have a brief conversation about why calculus is important. And that's really it. There's no homework other than you to read the course description and answer just a few really quick multiple choice questions. The course description, it's like how we grade, and how do you get extra credit in my class, and what do the tests look like? How does our history of AP exam scores look? All of those things. I have a document where you just have to answer some multiple choice questions, and it's the easiest thing to get a perfect score on because the questions are pretty straightforward, and that won't take you very long. This is due Monday. All right, this would be due in class Monday. And remember, it's only going to be the first few topics, everything besides the trig. All right, if you have not done anything with the trig, that is totally okay. All right, some of you can't do much with the trig because you're still going to be learning trig. So only topics A through Q. And topic V, some of you may not be able to do yet because you don't have your Inspire, but you're all going to have one by tomorrow. Okay. And then if I go back up, I think we had a question still on topic Q. Yep, still on topic Q. I think I hit Catherine's, but I didn't hit Ian's. 5 and 6. So yeah, kind of the same thing, except just different graphs, right? So let me help you with these. F of x is the square root of 9 minus x squared. Interesting factoid. You ready for this? This problem here, a student had to have some knowledge about how to graph that to score some points on the 2019 AP Calc exam, which is kind of interesting. So the graph of the square root of 9 minus x squared, if you use the calculator to sketch it, I don't have a problem with that at all, but I want you to hopefully in the future be able to handle this without a calculator. It is a half circle. It's a semicircle centered at 0, 0 with a radius of 3. I'll let you guys think, what if that 9 was a 25? What would the radius be? Good. Yeah, you guys got it. 5. I heard you through the computer. If this was a 64, the radius would be nice, 8. You guys are really good at this. So got this semicircle right here. And basically, I want to know what is the area between it and the x-axis. So you might have to break out your area of a circle formula, cut that in half. You're good to go. With number 6, Again, the key, I think, is more of the graphing than anything else. So sketch x plus 1 first. This is a piecewise function. X plus 1 has a y-intercept of 1. It's got a slope of 1, up 1 over 1, up 1 over 1. I could cheat and go down 1, left 1, down 1, left 1. But take a look at this, guys. He's got a domain restriction. X has to be less than or equal to 2. So I don't want to graph it anymore this direction because X says 2 is where we stop. And so I could connect all these dots, and thus I could have this shape. Okay, so far so good. And now I do the same thing to 5 minus x. Now 5 minus x, kind of tricky, would have a y-intercept of up here 1, 2, 3, 4, 5, which is right there. Don't be fooled. That 6 is actually the very top of the graph. But see, I don't really want to graph anything there because I can only sketch this when x is bigger than 2. But I can still use the slope -1 to go down 1 over 1. Okay, down 1 over 1. And now once I'm here, once I'm at that point there, now I can continue down 1, right 1, but I'm only going to draw the graph from that point. All right. Don't forget the x-axis is always part of the shape. And now your cattle will no longer roam free, right? Because you have this shaded region. And I'm going to let you guys research what the area of a triangle is, right? If you've forgotten. Excuse me. Space-time size, excuse me. And then you can use that to find that area and boom, you're off and running. You're off and running. And you guys, I think, if I'm not mistaken, I think I got all the questions in the chat at this point. And I try to keep the videos around an hour to an hour 15, but if anybody has anything else, I could certainly continue to help. I'm gonna go ahead at this point.
I have a quick question about the
sure.
last problem.
Okay,
Sorry.
yeah, no problem.
Would you minus that half square because it's after x equals 0?
On number 6 here.
Yeah.
Did I?
Am I overthinking it or am I?
Would I subtract? Because we're going with the area between the graph and the x-axis, anything that's like enclosed by both of those. So it looks like we're just going to have this triangle. Let's make sure that this triangle works out nicely. So the bottom, the base of this triangle, oh golly, Catherine, what is that? 1 block, 2, 3, 4, 5. Do you agree that that's 6 blocks probably?
Yeah.
And then the
So it's going to be 6 and 3. But I was wondering about the limitations between x equals 0 to x equals 5. Are we cutting off that like?
Oh no, this little tiny triangle, yes, you want to keep it. You want to keep that in your shape because we didn't say that we're using like the y-axis to be part of our fence or whatever.
Okay.
We're like in here, definitely we used x equal. Oh, wait a minute, Catherine. I see what you're saying.
I don't mean to be complicated.
Directions.
I'm so
No,
sorry.
no. These directions. Find the area between the x-axis and f of x from x equals 0 to 5. This should apply to problems 2, 3, and 4 only.
Okay.
Once you get to 5, it's just x-axis. I need to retype this and make that a little clearer. I see what you're saying, because if we apply the x equals 0 and 5, that does change the shape big time. And I guess on this one, it doesn't make a lot of sense on this one because you'd have this quarter circle, but 5 is way over here. So let me double check. None of these are going to get graded for correctness. So if a kid has like a kind of a misunderstanding, yeah, I'm glad I kept the video going and didn't stop the recording because that could help others that will watch this.
Yeah.
But no, thanks. Yeah, 5 and 6 kind of stand alone. Just x-axis is a boundary.
Okay. Thank you so much.
Yep. No problem. I'm going to go ahead and stop the recording. Those of you that were watching the recording, hopefully this helped you out, and you guys are going to just rock this packet.